Hello learners and welcome to my channel. So in this video, we will have probability density functions of continuous random variables, particularly the triangular distribution. Example, let x be a continuous random variable with probability density function f of x equals 1 minus the absolute value of x for x greater than -1 but less than 1. Find the probability that x is greater than -1 but less than 1. First, we need to draw the graph of this function. So if we give values for x, let's say if x is -1, this is going to be absolute value of -1, that's 1. 1 minus 1 is 0. So we have -1, 0. That's a point here. And then if x, for example, is 0, 1 minus 0 is 1. So we have 0, 1. So 0, 1 is this point here. And then if x is 1, then we have 1 minus 1, that's 0. So we have 1, 0. So 0.10. And of course, we have some points in between. So if we connect them, we will form a triangle. And this is a probability distribution because if you will get the area of this triangle, that is equal to 1. And as what you can see, all the values are above the x-axis. So they are non-negative. So for the probability that x is greater than -1 but less than 1, it's the entire triangle. And of course, the area of that is 1. But if we will use the area of the triangle as base or 1/2 base times height, or you can have base times height divided by 2, then we need to identify the base. The base is from -1 to 1. So that is 1 minus -1. That is 2 units. And for the height here is the y value or f of x when x is 0. So 1 minus 0, that's why we have this one here, y value when x is 0. So we have 1 minus -1 is 2, 1 minus 0 is 1. So the base is 2 and the height is 1. So 1/2 of the base times height, that is 1/2 of 2, which is 1. Another one. The probability that x is greater than -1 but less than 0. So it's that triangle. As what you can see, it's half of the big triangle. So of course, the area is also half of 1, which is 1/2. Or if you want to use the formula for the base for the triangle, that's 1/2 base times height. You will have 1/2 times the base is from -1 to 0. That is 0 minus -1. That's why we have this one here. And for the height, that's 1 minus 0. That is the y value when x is 0. So our base is 1, this one, and the height is also 1. So 1/2 of 1 times 1 is 1/2. Letter C, probability that x is greater than 0 but less than 1. So it's the other half. So of course, it's also 1/2. Base is from 0 to 1. That's 1 minus 0. And then height is y value when x is 0. So it's also 1. So 1/2 times 1 times 1, that is 1/2. Next, letter D, probability that x is greater than -1 but less than -1/2. So if -1/2 is here, then the triangle is this one. So base is, or we will use the formula of the triangle, 1/2 base times height. But what is the base here? From -1 to -1/2. That's -1/2 minus -1, which is positive 1/2. And the height is the y value when x is -1/2. So 1 minus absolute value of -1/2 is also 1/2. So 1/2 times 1/2 times 1/2, just multiply the numerators, multiply also the denominators. That is 1/8. So the probability that x is greater than -1 but less than -1/2 is 1/8. So this one here is the base and this is the height. How do we get the base? since that is from -1 to -1/2, it's just -1/2 minus -1. And of course, the height is the y value when x is -1, 1/2. Actually, if you have this kind of triangle here, the base and the height are always the same. So if the base is 1/2, the height is also 1/2. Another one, probability that x is less than -1/4. So there we have a triangle with the same base and height. So base is from -1 to -1/4. That's 3/4. So if the base is 3/4, the height is also 3/4. 1/2 base times height. So 1 times 3 times 3 is 9. 2 times 2 times 2 times 4 times 4 is 32. So the probability is 9/32. Yes, don't forget the formula for the area of the triangle. 1/2 base times height. Since this is a right triangle, the base is this leg and the height is this leg. F. Probability that x is greater than 3/4. So 3/4 is there. And this triangle is the area that represents the probability. So the base of that from 3/4 to 1, that's 1/4. And of course, the height is also 1/4. So 1/2 times 1/4 times 1/4, that is 1/32. So the probability is 1/32. G, probability that x is greater than -1/2. Okay, this blue part here of the triangle. So as what you can see here, it's like the whole triangle with a cut here on this part. You cut the small triangle. So for the area, we will subtract the area of this small rectangle from one whole, or from 1, because the area of the big triangle is 1. If we will get the area of this, the remaining will be the area of this colored part here. So what is the area of this small one here? This is a triangle with base 1/2 and height 1/2. So that's 1/2 times base times height. 1/2 times 1/2 times 1/2, that's 1/8. So 1 minus 1/8 is 8/8 minus 1/8, that is 7/8. So the area of the shaded part is 7/8, and that is also the probability that x is greater than -1/2. How about the probability that x is greater than -1/8? So again, we will remove, or we will subtract the area of this triangle here from one whole, because 1 is the area of the whole triangle. So the base of this triangle is from -1 to -1/8, that's 7/8. The height is also 7/8, same base and height. So 1/2 times 7/8 times 7/8 is 49/128. And 1 minus 49/128 is 79/128. So that is the area of this shaded part here, which is also the probability that x is greater than -1/8. Another one, probability that x is less than 1/4. So where is 1/4? Here on the right of 0. So less than 1/4. So here it's like also a triangle, the whole triangle with a cut part here, this part here. So we need to identify the area of this, subtract from one whole, and we will get the area of the shaded part. So the base here is from 1/4 to 1, that's 3/4. Height is also 3/4. So 1/2 base times height. So 1 minus 9/32. And 1 is 32/32, so 32 minus 9 is 23. So the probability or the area is 23 over 32. That is the probability that x is less than 1/4. Next, probability that x is less than 2/3. So 2/3 is there. So same process. We will subtract the area of the small triangle from the area of the big triangle, which is 1. So 1 minus the 1/2 base times height. The base here is from 2/3 to 1. That is 1/3. So same with the height. So 1/2 times base times height, though. So 1/2 times 1/3 times 1/3, that is 1 over 18. So 1 minus 1 over 18 is 17 over 18, not 81. 17 over 18. Next, probability that x is greater than negative 1/2 but less than 1/2. Where is negative 1/2 and 1/2? Or where are they? Here, negative 1/2 and 1/2 here. So the figure looks like this. So we need to identify the area of the shaded part. So to get that area, we will subtract the area of this small triangle and the small triangle from 1, because the area of the whole triangle is 1. So 1 minus this one here is 1/2. Base is from negative 1 to negative 1/2. That's 1/2. So 1/2 also the height. So 1/2 base times height. Plus this part here from 1/2 to 1. That's also 1/2. So 1/2 base is 1/2. Height is also 1/2. So we get the sum of the two triangles and subtract the sum from 1. We get 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So 1/8. And this one is also 1/8. 1/8 plus 1/8, that is 2/8. 1 minus 2/8, that is 8/8 minus 2/8, which is 6/8, which can be simplified to 3/4. Another one, probability that x is greater than negative 1/4 but less than 3/4. So the area looks like this one. So how do we find the area of this? Find the area of this triangle and this triangle and subtract the sum from 1. So 1 minus 1/2, the base here is 3/4. The height is also 3/4 for this one. And for this small one here, we have base from 3/4 to 1. That's 1 minus 3/4. That's 1/4. Height is also 1/4. That's why 1/2 base times height. This part here is the area of the small triangle here. And this one here is the area of this bigger triangle here. And then if we add the areas and subtract from 1, that will be the area of the shaded part. 1 times 3 times 3 is 9. 2 times 4 times 4 is 32. 1 times 1 times 1 is 1. 2 times 4 times 4 is 32. 9 plus 1 is 10. So 1 minus 10 over 32. That is 22 over 32, which can be simplified to 11 over 16. So the area of the shaded part here is 11 over 16. And that is also the probability that x is between negative 1/4 and positive 3/4. Okay, let's have a second example. Let x be a continuous random variable with probability density function f of x equals 1 minus absolute value of x minus 1 for x greater than 0 but less than 2. Find the probability that x is less than 0.2. So we need to graph this one. How does the graph look like? Let's have, when x is 0, this is 0 minus 1, that's negative 1. Absolute value of negative 1 is 1. 1 minus 1 is 0. So we have 0, 0. So this point here. How about when x is 1? 1 minus 1 is 0. 1 minus 0 is 1. So we have 0.11. So 1, 1. When x is 2, 2 minus 1, that's 1. 1 minus 1, that's 0. So 2, 0. Okay, if we connect, okay, that will be like that. So it should be, by the way, it should be a hollow circle here and here. But anyway, it does not matter because this is a probability. Where is point 2? Here. Point 2 is just here. So probability that x is less than 0.2 is just the area of this triangle here. So that's a triangle with base 0.2 and height 0.2. So 1/2 of 0.2 times 0.2, you can put that on your calculator. That's 0.04. No, 0.04 divided by 2. 0.04 divided by 2 is still over 2. So that's 0.02. 0.2 times 0.2 is 0.04, but we didn't divide yet by 2 here, so that's 0.02. So this one is the area. So that is also the probability. Probability that x is greater than 1.2. So 1.2 is here. So greater than, it's on the right of 1.2. So that's a triangle with base from 1.2 to 2, that's 0.8, and height also 0.8. So 1/2 0.8 times 0.8, that's 1/2 of 0.64, so 0.32. So the probability that x is greater than 1.2 is 0.32. How did we get 0.8? That is the distance from 1.2 to 2. How do you get that? 2 minus 1.2. That's 0.8. And then for here, you can have the height of the graph, that is the y value when x is 1.2. Or you can just have that the triangles that we make here are always, what do you call this? Isosceles, right? Meaning to say the base is the same as the height. Letter C, probability that x is greater than 1 but less than 1.6. So this one. So how do we get this area? We will just subtract this part here and here from 1. Or simply, we can subtract this one here, the small triangle here, from 0.5 because this is anyway half already. So we have 0.5 minus 1/2 of, what's the base of this triangle here? Base is from 1.6 to 2, that is 0.4. Height is also 0.4. So 0.4 times 0.4 is 0.16 divided by 2, that's 0.08. So 0.5 minus 0.08, that is 0.42. So this one here is 0.08. So this one is 0.42. This one here is 0.5. So the total is 1. Letter D, probability that x is greater than 0.5 but less than 1, this one. So we will subtract from 1/2 the area of this triangle because this one here is already 1/2 or 0.5. So the area of this triangle here is, that's a triangle with base 0.5 and height 0.5. So 1/2 base times height. So 0.5 times 0.5 is 0.25 divided by 2, that's 0.125. 0.5 minus 0.125, that's 0.375. You can use your calculator for this one. So 0.375 is the area of this shaded region here. So that is also the probability that x is between 0.5 and 1. Letter E, probability that x is greater than 0.4. Subtract the area of the small triangle from 1. So 1 minus 1/2 base is 0.4. Height is also 0.4. So 0.4 times 0.4 is 0.16 divided by 2, 0.08. 1 minus 0.08 is 0.92. So the area of this part here is 0.92, and that is the probability that x is greater than 0.4. This is 0.92. And this one here is 0.08. So the total is indeed 1. Probability that x is less than 1.7, this one here. So just subtract the area here from 1 whole. You get area here is 1/2. Base is from 1.7 to 2, that is 0.3. 2 minus 1.7, that's 0.3. Height is also 0.3, so 1/2 base times height. 0.3 times 0.3 is 0.09 divided by 2, that's 0.045. 1 minus 0.045 is 0.955. So this one here is 0.955. And this one here is 0.045. And the total is 1. Letter G, probability that x is between 0.2 and 1.1. So this one here, subtract the area of this small triangle and this big triangle from 1. So this triangle here has a base 0.2 and height 0.2. So 1/2 base times height. So this one is for this one here. And this one is for this triangle here. So from 1.1 to 2, that's 9 or 0.9. That's why 0.9 times 0.9. So 1/2 of 0.2 times 0.2. 0.2 times 0.2 is 0.04 divided by 2, 0.02. 0.9 times 0.9 is 0.81 divided by 2. That's 0.405. So this one here is 0.02. And this one here is 0.405. If you add the 2, that's 0.425. And if you subtract that from 1, that will give you 0.575, which is the area of the shaded part here. So 0.575, the other one is here is 0.405. And here it's 0.02. Probability that x is greater than 0.8 but less than 1.4. Okay, we will find the area of this triangle and this triangle. And we subtract the sum from 1 whole to get the area of this shaded part here. So this is a triangle with base 0.8 and height 0.8. And this one here is a triangle with base 0.6 and height 0.6. From 1.4 to 2, that's 0.6. From 0 to 0.8, that's 0.8. So we have here 0.8 times 0.8 is 0.64 divided by 2, 0.32. 0.6 times 0.6 is 0.36 divided by 2, that's 0.18. So this one here, 0.18 is this one. And 0.32 is this one. And then if we subtract, or the total of that is 0.5, so 0.5. 1 minus 0.5 is 0.5. So this area here is 0.5. So the probability is 0.5 or 50%. Okay, so that's it for the probability density function of continuous random variables, particularly the triangular distribution. If you have questions, you can comment down below. Don't forget to click the like button and share this video with your classmates. Till the next video, bye! Thank you for watching. Comment, like, and subscribe. Bye!